In this PowerPoint, we're going to investigate what we call in mathematics the unit circle. Proceed to the next slide. Here we're going to talk about the unit circle. The unit circle is a circle of radius of 1 unit, which means that here's the center of the circle, and this here would be 1 unit across. So the radius of the circle is 1 unit. That's what it means by the unit circle. So we go up 1, go to the left 1, go down 1, and any point on the circle is 1 unit away from the center. Okay, when we're measuring angles with the unit circle, we start at this point over here at 0 degrees, and we go around in an anti-clockwise direction. That's the convention. It was decided a long time ago that this is what we do. We just have to accept that's where we start, and that's the direction we go in. So this way is considered to go in a positive direction. If we actually went in this way here, in the clockwise direction, it would be a negative angle. For year 10 trigonometry, we're only worried about going in a positive direction, starting at 0 at this point. So if I travel 1/4 of the circle around, I'm now up at 90 degrees. If I go another quarter of a circle around in the positive direction, I get to 180 degrees. If I go around into another 90 degrees, I get 270 degrees. And if I do a complete lap of the circle, I've traveled 360 degrees. Okay, for ease of use and things like that, we refer to the 4 different sections of the circle. That the first quarter is called the first quadrant, which is between 0 and 90. 0 and 90 don't actually belong to the quadrant, so it's actually between 0 and 90. If we go across to the second quadrant, the second quarter of the circle, that's all the angles that sit between 90 and 180, but the angles 180 and 90 don't belong in any of the quadrants, so that either does 270, 0 or 360 don't belong in the quadrants. It's the angles between these numbers. So the third quarter of the circles we call the third quadrant, and obviously the fourth quarter of the circle is the fourth quadrant. So simple starting thing here is we're asked state the quadrant of the unit circle in which the following angles is found. 78 degrees is between 78 degrees would be somewhere up here. This is about where I'd find 78. It's between 0 and 90, so we would find it in the first quadrant. 145 degrees sits between 90 and 180, is actually halfway. That's in the second quadrant. And 282 is bigger than 270, but less than 360, so it's over here somewhere, and therefore it's in the fourth quadrant. So one of the things we need to be able to do is know which quadrant the angles are in, so we split them up into lots of 90 to determine the quadrants. Okay, we'll proceed to the next slide. Okay, we have 3 functions or 3 rules that come from the unit circle. They are called sine of theta, cosine of theta, and tangent of theta. And it works like this. So we have a right angled triangle containing the angle theta. So if you look at the diagram here, this is theta here, right, the size of the angle. And we can see it's constructed in the first quadrant of the unit circle. We say the length of the y-coordinate, this length along here, whatever the y-coordinate is, so it's that height, that's actually equal to the value of sine theta. So the y-coordinate is sine theta. If I'm just trying to think of a good colour to use here, we'll go yellow. If we look at the length along here, how far across this point is, okay, the x value, we say the x-coordinate of point P is equal to cosine of the angle. So that's where sine and cosine come from. They actually come from this special right angled triangle that's made in the unit circle. So the hypotenuse always here is 1. because it doesn't matter where I move that, the radius of the circle is going to be 1, that's always going to be the hypotenuse. This number here, y, the height of how high p is up, that's equal to sine theta, and the width, how far across p goes, it determines the cosine of theta. So that's the definition. Cosine and sine are actually lengths. The lengths of lines in this triangle, in the special triangle formed inside the unit circle. The unit circle means the radius is 1, which means the hypotenuse is 1. Okay, there's a special rule that we can learn from this, which was mentioned on one of the videos in the previous PowerPoint, that tan of theta can be worked out by dividing sine by cos. This is a fact that we need to learn, or dividing the y coordinate by the x coordinate. It's the same thing. What tangent means, we'll see in the next slide, what the actual tangent of an angle is measuring. The thing I'd like you to remember from this is that these, all three of these, are measures of length. Okay, so what we're actually talking about here is the length of the sides of this triangle's form. So if I put P somewhere else, probably better if I draw another one here. So here's my unit circle. If I put P somewhere else, so here, this has a coordinate xy. Alright, so on the Cartesian plane, y's here and x is over here. Okay, this point here, which we're going to call P also, the angle made going up to P from starting at 0 degrees over here, to form that triangle, that makes a triangle. Might be better if I draw that like that, makes that triangle. That this length here, which is actually the x value of that point, that's equal to cosine of theta, and this length going up here is equal to the sine of theta. Alright, the tangent of theta is something different about this circle, which we'll show on the next slide. Oh, sorry, if we then did another unit circle here, just to illustrate this point, if the angle's bigger than 90, okay, where most of our trigonometric work's been restricted to triangles where the angles are less than 90, but if I put point P over here, it means that I'm travelling around the circle around to here. So the angle I'm talking about, theta, is this. But what we do here is, so we can still make a right angle triangle, but we drop it this way. Okay, so this is the y value of that angle. So the y value of that point, that's going to be sine again. That's going to be sine of theta, is that length there. And this length here is going to be x, which we know is cosine of theta. Alright, let's go to the next slide. Okay, here we have our unit circle, and we're asked several questions here, but before we start answering the questions, we'll look at the particular circle. So normally we say the point on the circle here is point P. The angle here is the angle that makes point P. In this case, we're actually looking at the 30-degree triangle. That's 30 degrees. And from here we form the right angle triangle. So we see the red line there, and then we extend that back across here, and our right angle triangle is there. Okay, the definition of what sine of the angle is this length here. It's the y coordinate of y, how high up it is, or what the y value would be at that point. we can read across here on the y scale that it's 0.5. The sine of 30 degrees is 0.5. That's something we've already learnt from our exact values, that sine of 30 degrees is equal to 0.5 or a half. The x value of point P, which is down here, the length of this line here, is what we call the cosine of the angle. Our angle here is 30 degrees, cosine of 30 degrees, we read off our scale here, it's going to be approximately 0.87. Keep in mind we're talking about the unit circle here, so the hypotenuse here is 1. The tangent of a angle is worked out like this. This line here, from here to here, is called the tangent line. It's called the tangent line because it just touches the circle at 0 degrees. A straight line that only touches the circle at one point, and it's at this point here. So this is called the tangent line. This is actually how we work out the value of tan of whatever the angle is. And it's worked out like this. Here's 30 degrees, hits the circle there, but if I extend that line so it comes through, the value of tan theta is the height from the 0 line. So that length there would be tan of 30 degrees. So tan of 30 degrees here would estimate somewhere it's about 0.57, which if you do it on your calculator you'll find that's pretty close to the right answer. If I move P around the circle, so let's do a new one up here. Let's go up here somewhere. Let's go to this point here. This is going to be exactly, from experience I know this, if I put P here. So let's make this the new P. We'll call this P dashed, something. Now it's not the same as this P, it's just another point we're picking. If I draw a line from the middle of the circle to point P, then I get a new triangle. So I'll just use yellow here to show the triangle. It comes down like this and across like this. So that's my right angle triangle here. So now the sine of this, a new angle that we've got here, and our new angle is this size. In fact, I know from experience this one is 60 degrees. Okay, so the sine of 60 degrees is the height of this line, so if I read across here, and not surprisingly, it's the same number as we had for the cos of 30 degrees, because we know the 30 degrees and the 60 degrees triangle are related, so this is 0.87 from here to here. That's the height of that triangle. The width of the triangle is going to be the cosine of 60 degrees, and we can see that it's 0.5. Alright, so up till now we've been investigating triangles where we only consider this first quadrant where all the angles are less than 90, but the unit circle allows us to investigate triangles that are bigger than 90 degrees. So for instance, if I start here, remember we start from this point here and go around in an anti-clockwise direction. If I kept going right around, and let's say I hit the triangle, I want to stop here in the circle, then if I draw a line from this point here to the origin, let's call this point P double dash, the second version of P. My angle now is I'm starting down here and I come right around to here. That's the size of my angle, which we'd call theta. I actually know that this here, by using my symmetrical properties, that this angle here is 150 degrees. Because if that's 30 degrees here, that's 30 degrees here, then that's got to be 30 degrees there. So the angle starting from 0, going around in an anti-clockwise direction, going around this way here, I would have travelled 150 degrees around the circle. Right, from this triangle, from this point we form our triangle. We go straight down and then straight across. We always go to the x-axis to make the triangle. So my right angle is always touching the x-axis. The height of this triangle is the y value. The width of this triangle is the x value. Now we can see the y here is going to be 0.5. So what we find is the sine of 150 degrees, because remember we said this is 150 degrees. Sine of 150 degrees is equal to 0.5. The cosine of 150 degrees though, the cosine of 150 is equal to the x value. The x value here is, it's 0.87, but it's actually negative 0.87. So we find cosine is negative in this second quadrant. In fact, if we talk about this, they're all positive here. Sine, cos and tan are all positive in the first quadrant. In this quadrant here, we find only the sine is positive. We'll write this all in a minute. Why is the tangent not positive here? Because if I extend this line and go through the origin, I need to then extend across here until I meet the tangent line, and this value here would be a negative value from 0. That length there is in the negative direction. It's above, it's in the positive direction. If I had some angle way over here in the third quadrant, I might change this to a different color. Okay, so if I want to go to this position here, let's call this the third version of P, 1, 2, 3. Okay, starting from 0, I need to travel around the circle all the way to here, so I'm somewhere between 180 degrees and 270 degrees. But once again, we form our triangle like this, go up to the x-axis, make a right angle at the x-axis. The sine of the value would be this length here, so sine is actually going to be negative, whatever it is, about 0.87. The cosine is the length along the x-axis, which is also going to be negative. So cosine is going to be negative, sine is going to be negative. But why is tan positive? Because if I extend this line where P is until it hits the tangent line, way over here, I get a positive value for tangent. So only tan is positive in this quadrant. And when we get to the fourth quadrant, so I'm going to pick a point here. I'll just try and change colors if I can. Let's make it light blue. So I'm going to go a point here somewhere. Let's make this the fourth version of P. Okay, so I draw the line from the center of the circle to point P. So the angle I've traveled is all the way around like this. Okay, so somewhere bigger than 270 degrees and less than 360. We draw the right angle triangle going back to the x-axis, making a right angle there. This would be the sine of this angle, and so it's going to be a negative value because y is in the negative sections here, so you can see it's going to be about negative 0.8. And the cosine of this angle here is this length here. This is in the positive direction of x, so it's going to be about, looks like about 0.6 something. And the tangent, if I extend this line so it meets the tangent line, it's going to meet it down here somewhere, and that's going to be a negative value from going down. It's a negative value. So we find the only thing positive in this last quadrant is cosine. So we normally summarize that, and we'll put that in the next page, but sometimes there's a little, people learn mnemonics to learn things. So one we learn when I was at school, it was all stations to the city. I lived near a train line, so it was relevant. Lived down in Dramana, it's not so relevant. So another one might be all students okay, all students, S for students, talk, T for tangent, and there's lots of different words we can put here for C, but one that we can all remember is all students talk consistently. So all students, actually, what is all students talk consistently, and that helps us remember what's functions positive in which quadrant. All positive in the first quadrant, sine in the second quadrant, tan in the third quadrant, and only cos in the fourth quadrant. Okay, let's try and answer the questions here in that match up with this diagram. So what's the maximum value sine can be? Sine is the y value. The highest the y value can be on this circle is up at positive 1. So the answer we're looking for there is 1. Keep in mind that all these answers are on the next slide, nice, neatly typed. What's the smallest value sine can go to? What's the lowest that y can go down to is down here, which is negative 1. Okay, now we just went through this. Where is sine positive? Sine is positive in the first quadrant, second quadrant. In the third quadrant we find it's negative, and the fourth quadrant is negative. The cosine, the x values are positive in the first quadrant. Okay, in the second quadrant the x values are over here. The x values are negative, and that's the same for the third quadrant and the second quadrant. So they're both negative in the second and third, but cos then uses positive x values, so it's positive in the fourth quadrant. Tan, we talk about how it meets the tangent line, or we can use this shortcut where it's the y value divided by the x value, sine over cos. Positive divided by positive makes positive. If we have a second quadrant, we've got a positive divided by negative, so that's going to make a negative answer. Third quadrant, negative divided by negative makes a positive answer. But we can see we've already worked that out over there in the circle, and that's the t. And the fourth quadrant we find that tan is negative. So we summarize this as all students talk consistently. Some wag once said all students talk crap. I wouldn't agree with that. Okay. Then we've got question 4 to answer here. So sine of 30 is, what's the y value when we've got 30 degrees? That's this original blue line here. The y value is 0.5. Right, we're using our unit circle here to estimate this, so we're only approximating. Cos of 30 comes down here and looks to me it's about 0.87. If you go to your calculator, you can get the exact values. Tan of 30 degrees is, we extend this line and it's where it's going to hit up here, so it'd be roughly about 0.57 we said before. Sine of 200 degrees is somewhere around about here. Sine would be the y coordinate here, so that's about negative 0.3. Let's go across here, about 3.4, so it'd be negative 0.34, which it is, if you go to your calculator. On the next screen, I've got all this nicely typed out. The cosine of 210 degrees, when we talk about 200 degrees, sorry, 20 degrees past 180, right, the cosine is the x coordinate here, so it's going to be negative, and it looks like it's about 0.9. In fact, it's about 0.94. And the tangent, so we extend this line so it keeps going back through here until it hits the tangent line, and here it looks like we've got just a bit below 0.4, it's in fact positive 0.36. If we go to the next slide, we can see a nice version. Okay, so there we've got all the answers here. What you probably should have minimum on your diagram here is, we call that, we've got an A there, an S there, a T there, and a C there as a reminder of what functions are positive in which quadrant. Remember that we start at 0 degrees here, and that's the positive direction here. This is the tangent line. This is also the first quadrant, second, third, ooh, not very good, 3. I'm going to rub that out and start again. Third quadrant and the fourth quadrant. Okay. Copy those down into your notes, and I think from here we will doing some questions out of the book. Go to the next slide and you see which ones they are.